So this lesson 4.7 is on absolute value inequalities. So this whole chapter we've been working on inequalities, regular one-step, two-step, compound inequalities. Now we're going to be talking about absolute value inequalities. And when we talk about absolute value, anything that we put into that absolute value symbol will always come out positive. That's something that we have to remember. So when we have an absolute value symbol, we can put a positive number in there and solve whatever's in the absolute value. And when it comes out, it's going to be positive. Or we could even put a negative x or negative value for x in there, and it could still come out. It will still come out positive, meaning that when you're talking about absolute value inequalities, you will have multiple solutions. Okay. There are two types of absolute value inequalities. Or compound inequalities. There's conjunctions and disjunctions. And I'm not sure that we went over this when we did our compound inequality homework in 4.6. Did we discuss conjunctions and disjunctions?
I don't think so.
Okay, conjunctions are when you graph a compound inequality and you connect those circles together. That means that the answer to that compound inequality can be any number in between the two numbers that we graphed. Okay, it could be any of those numbers. That's a conjunction because they're connected. And when you look at a conjunction, it would be graphed like this, where the two circles are connected together. Now, we didn't graph it like this. We graphed it to where we just connected the two dots like this. Okay, so that is called a conjunction. It will use the word and when you're talking, when you're looking in your text, and it will be written together as a compound inequality where X is in the middle and your numbers are on the outside, and then it is graphed like that. Okay, so that's a conjunction. It's all together. In the English language, the prefix con means with. So when I think of the word with, I think it's just put together. You're with the other part of the inequality. All right, the disjunction is on the other side. That is when your inequalities are separate. So we graph where one goes in one direction, one goes in the other direction. When you have an inequality that is graphed that way, you do not write them as a compound inequality. You write them as two separate inequalities. So it has this word or in between the two inequalities, and you're also solving them separately. And it will use the word or. Okay. All right. So that is the difference between a conjunction and a disjunction. Okay. Let's go ahead and go to the next page. We are going to start graphing these. One thing that I want to go over with you before we begin is how do you determine if you're working with a conjunction where you're going to set up a compound inequality altogether with that X in the middle versus an absolute value inequality where you separate them out by the word or, right? And your arrows go in opposite direction. So how can you tell the difference between that? Well, if you look right here, if the absolute value is less than something, then you are going to write it as a conjunction. So if it is less than, you'll write it as a conjunction. Okay. Right. If, on the other hand, your absolute value is greater than, then you are going to write it as a disjunction with the word or. Okay. So just disjunction. All right. Now let's go ahead and start. So you're going to set up your inequality, your absolute value inequality set greater than or less than a positive version, and then greater than or less than a negative version. So what does that mean? So we're trying to figure out what value can we put into X to make that less than 7? Give me a number. What's the number we can put into this to make it less than 7?
4. 2.
4, 2.
1.
1.
-4.
-4. Because if I place, what'd you say? -200. What's the absolute value of -200?
200.
Is 200 less than 7?
No.
No, so it can't be -200.
Wait,
So
anything past -6 is actually more than 7
Or equal to. You're talking about absolute
Yeah.
value, yes.
yes, right. But it could be -6.999999999. So it could be that also. Okay, so how do we figure this out? What we do is we take our absolute value here, and because it is less than, we have less than up here, we're going to set it up as a conjunction. So I have my X in the middle. I put my inequality symbols. And on this side, I have a 7. On this side, I have a -7. And what this means is that X inside that absolute value symbol can be any number in between -7 and 7. Okay, so, and it can't be -7 and it can't be 7, but it can be anything in between. That's what, without the equal sign, that's what it's saying. So once you have this, you will then graph your answer. Okay, so let's come over here and graph that.
We have to list all the numbers it could be.
No, that's why we're graphing the inequality this way. This already tells us, by graphing this inequality, it tells us that our X could be any number between -7 and 7. By writing the inequality, that tells us it could be anything between -7 and 7. That's why we have this type of notation, so that we don't have to write every single number. Okay, yep. All right, number 2 is the same thing that we just did. Our inequality is showing that the absolute value is less than. So because it is less than, according to our notes up here, we can write it as a conjunction. So I have X is less than 3, but it is also greater than -3. And then I will graph that. So we have -3 and 3. Now this graphing should just be a review because we've graphed a lot since the beginning. Okay, look at example 3. Notice that the absolute value is now not less than, but it is greater than. Referring up to our notes up here, if it is greater than, we set up 2 separate inequalities separated by the word or, because this means that it's not going to be in between 2 numbers, but it's going to be on either side of 2 numbers. Our answer will be, or our solutions. So the way that we do this is we set it up as X is greater than 2. Oh, sorry. X is greater than 2, just like it is in the problem, but without the absolute value symbol. Or X is, now when we do this, we flip our sign and we make the number the opposite. So instead of greater than, it's less than, and then -2. That is our answer written algebraically, and then we graph it.
So if we do this in like the right,
Yes, because they're both that answer. So when you graph it, X is greater than 2, or it could be less than -2. And notice we have graphed a disjunction rather than a conjunction. Okay. Example 4 is the same as example 3, just with a different number. So go ahead and work on that one. Okay, any questions on those first four?
We have to have the arrows or not?
Yes. Because that tells us that it goes on to infinity. It can be any number. All right, so example 5 and 6, similar. I'm gonna do 5 and 5 with you. You're gonna do 6 on your own. So now we're actually having to solve some stuff. So are we going to write a conjunction or a disjunction with this inequality? Conjunction, because it's less than. So again, just like when we have the X up here, and we wrote that in the middle with these two symbols, and then this solution on this side and this side, we're gonna do the same thing down here. We're gonna put, but this time it's 4x. So we're gonna put 4x in the middle. Our two symbols. And then we have a +8 and a -8. Now, one thing you need to remember is that and I'm just gonna reiterate something that I've already told you. The proper way to write a compound inequality is with the larger number on the right side and the smaller number on the left side. And so that's why we put the positive on the right and the negative on the left. Now, you solved these in our last lesson, so you should know what to do at this point. We will divide every term by 4. Okay. So I'm just going to take and divide this by 4, this by 4, and this by 4. And then you can graph that.
Are you fine if we just draw a line underneath the thing and put the, or draw a line underneath that and put 4, so we're dividing the whole thing? Just tear it down.
Oh, just draw one line with 1 4. Is that,
Yeah.
yeah, that's fine. Just don't get confused by that. Okay. Go ahead and do example 4. I mean, I'm sorry, 6. Yes.
We have to do like that, or can we just like solve it like it is and then write it the answer?
You mean, do I want you to write this step right here?
No, like, so you just leave the 4x less than 8, and then you just like put both sides over 8, I mean, over 4, and then divide them.
No, you need to do it like this. Ask Wyatt what I think about that. I know that what we're seeing here is the same number on either side of the compound inequality, but one's positive and one's negative. That will not always be that way, Brooklyn. So that's why I don't want you to do that. Because we're going to start getting to compound inequalities where these numbers are different. All right. Questions? So let's go ahead and go to page 3. Same type of problems. This time though, instead of a conjunction, we're working with disjunctions. So on this problem for number 7, we're going to set up one of our inequalities, just how it's written, but without the absolute value. So 6x is greater than 24. Then we're going to separate it by an or and write the other one, 6x, instead of greater than, we're going to write less than. And instead of 24, we're going to write -24. Okay. And then we solve both of those separately. And you should have 2 separate inequalities. And when we graph them, they will show a disjunction. So we will graph x is greater than 4. And x is less than -4. All right, go ahead and do example 8. Okay, go ahead and check your answer for that one. Any questions on those? Okay, now we're doing the same thing all the way through, but instead of having a 2-step multiplication problem, we're going to have a 2-step adding or subtracting problem. That's all it is. So for 9 and 10, looking at your inequalities, we'll see that those are both going to be conjunctions. So we're going to set them up just like we did the previous conjunctions with x in the middle. Okay, so we have x plus 1 is less than 3 and is greater than -3. And then we solve. Okay. So in this case, since we have a +1, we're going to subtract 1 on all sides. Okay. And notice this time our numbers are not the same. Our numbers are different. So we have a -4 and a 2. Okay, and then you graph that like we did the previous ones. And our arrows will connect this time because it is a conjunction. And I want you to try example 10 on your own. Check 10. Yes,
Do you want to split it like that, or do you want to split it, change the number?
either one works for me, whatever's easier. All right. Moving on to page 4. Same problems, but this time disjunction. Okay, so I'll set up that first one with you, and once we set it up, I'm going to have you finish it on your own and do number 12 on your own. Okay. So since it's a disjunction, we're going to set it up just like this. X minus 1 is greater than 5. And then separated by or, x minus 1 is less than a -5. Okay. And so then you'll solve both of those and graph them. Okay. When you finish 11 and 12, go ahead and check your answers. So far we've been working with just 1-step inequalities. And it's going to progress to 4-step inequalities. Or yeah, in just a minute. Okay. Are there any questions up to this point? Okay. Moving on, you can look at 13 and 14, their inequality symbols. One is a conjunction, one is a disjunction. Okay, so this one, we're going to set it up as a conjunction, meaning that 2x minus 3 is in the middle. You have a +9 on the right, a -9 on the left. Okay. And then we go ahead and solve it like a 2-step inequality. But remember, whatever you do in the middle, you do to the left and the right side. So in this case, the first thing we will do is add 3 to all 3 sides. Okay. And then we get rid of the 2 by dividing all 3 sides by 2. So you're basically just taking everything that you've learned about equations and inequalities and applying it to this. Okay, and then graph it. And then with the disjunction, you're setting up two separate inequalities. If you need me to stop or pause or hold for just a second while you work or process, just let me know. Okay. All right, so we have 6x plus 1 is greater than, oops, I forgot my one, is greater than 23, or 6x plus 1 is less than negative 23. Okay. And you're just going to solve these. So I want you to go ahead and solve those on your own and graph them. And we will check them in just a minute. Check 14. Questions? Yes.
Is it okay if we, when we write our answer, if we change it to a mixed number? Cause that's just easy to do that.
Yeah, for these, if it, yeah, I end up doing that too at the bottom. We did that.
Oh,
Okay, let's go to page 5. We're adding more steps here. We're now moving to a 3-step. And a lot of times people, when they see the number on the outside of the absolute value symbol, they're going to want to distribute. Do not distribute. Okay, people will say, well, it works. Well, sometimes it works, but sometimes it doesn't. And if you do this and it doesn't work, your answer is wrong. Okay, so we will not be distributing the term on the outside of the absolute value symbol. Instead, we will be dividing both sides by that 2. So that looks like this. Just going to take and divide this side by 2 and that side by 2. When we do that, these 2 2's are canceled out, and we have now the absolute value of 3x plus 1 is less than 2. When you are dealing with absolute value inequalities, just like absolute value equations, you always want to get rid of everything that is around the absolute value symbol before you start solving what's inside the absolute value. So get rid of everything on the outside first. Now, this is a conjunction, so I'm going to set my problem up. 3x plus 1 is less than 2, but it is also greater than negative 2. So we'll start solving that by getting rid of that positive 1 first. And divide everything by a 3. And then graph. Okay, the next one is the same, but it is a disjunction. Do we need to pause for just a minute? All right, so it's a disjunction, but first, before we set up that disjunction, we are going to get rid of that 3. So let's divide everything by a 3. And we have the absolute value of 5x minus 1 is greater than 4. At this point, you should be able to set this up as a disjunction right? So I want you to go ahead and set that up. If you forget, look at number 11 and 12, and that will help you set that up. Okay. Check to make sure you did that right, and I'm gonna graph this right now. Make sure your -3/5 is graphed between the 0 and the -1 and not the -1 and the -2. Okay. Yes,
Does it matter kind of where the fraction is as long as it's like, so if we put it in between the -1 and 0 and it's like not.
Yeah. I'm not, that's not, yep, I'm not checking that, just somewhere in between there. Okay. Now, we're gonna move to the next set. And this time we have 4 steps that we're doing. The first thing that we need to do is get rid of the -4 by adding 4 to both sides.
Wait, what?
Then we're gonna get rid of the 2 by dividing both sides by 2. Once we get rid of those 2 numbers around that absolute value, then we could set up our conjunction. Okay, so let's see what that looks like.
But I thought you divide the thing all the time beforehand.
We've added, we've added a part. You get rid of addition or subtraction first, and then we get rid of multiplication or division.
Have God. No, it's coming together.
It's the reverse of PEMDAS.
Wait, what?
It's not
Okay.
work here. It's segment.
Okay, let's get back to the problem, all right? So we're gonna add 4 to both sides. Okay, and then this is what you should have. Next, we have to get rid of the 2, so we're gonna divide both sides by 2. Now that we've gotten rid of everything around the absolute value, you can set up this conjunction. So I'm going to finish this one on your own. When you're finished, check your answer. No, that's good because, all right, moving to the last problem before we get to the last section, which is kind of short and sweet. Notice that example 18 is a disjunction, and I want you to try this one on your own, but just remember that when you set it up as a disjunction, okay? So we're working on this last problem. So this is what your 2 disjunctions should look like, and then we can finish solving.
They're talking shit about.
Wait, you forgot to subtract 4.
Yeah, I just noticed that on both of them too. Like that doesn't look right because the numbers were gonna be the same. So 4 and -12. Okay. Okay, so you should have gotten this disjunction. And then when you graph it, x is greater than 2/3 and less than -2. Yes, sometimes we automatically want to connect those circles rather than,
I did that,
yeah,
but you messed up, so.
Xavier. I'm still recording and some of you guys are still acting up, so let's stop, please. Okay, we have the last set of problems here that I want to go over. We have inequalities that by looking at them, you can automatically tell there are not going to be any solutions that will make the inequality true. Then there are some that when you look at them, you know that they will always be true, or all real numbers will fit that solution. So here we have inequalities with no solution. The reason that we know that there is no solution is because when you plug in the number and you try to solve it, it will not be true. For example, this clearly is not true because 3 is not less than -3. Okay. If you look at this inequality here, for example, 19, is there any value of X that we could place in that absolute value symbol that we can get an answer that is less than a negative number?
No.
No, because every number you put in here will have an absolute value of a positive number. Okay. But be very careful. Okay. Because look at this one right here. You end up with a negative number, but is there anything that we could put in X that will make it greater than -7? Yes. Any value that we plug into that absolute value symbol will come out positive and will always be greater than -7. The difference, there's no solution here. This one is all real numbers, meaning every number in the universe, no matter what number you put into that absolute value, will make that absolute value true. So for this one, we have, this will always be positive. Positive is never less than a negative. Okay. It is never less than a negative. Okay. So because of that, there is no solution. And that's all you put is you put no solution. Okay. For your answer. Does that make sense?
Yep.
That you can never put a number in an absolute value symbol and it be less than a negative number. They will always come out positive, which is always greater than negative. Here, whatever number you put in this absolute value symbol will always be positive, just like over here. But this positive number will always be greater than a negative number. It will always be greater. Every positive number is greater than a negative number. What that means is no matter what number we put into that absolute value will make the inequality true. We say that this is all real numbers. Okay.
So we're determining what's fake and what's real.
Now you say it's easy, but when you get to the homework, many of you will start solving it and not realize, oh, there was a negative. So anytime you have a negative on this side, make sure that you check to see if it's going to be no solution or all real numbers, because it will always be one of those. So what is this one right here? No solution. And you can abbreviate it. And then what's this one over here?
ARN.
All real numbers. Okay. Yes, Jake, did you have a question?
I was gonna ask if we can abbreviate it.
Oh, yeah. All right. And that concludes lesson 4.7.